Welcome to Share My Lesson. In today's video, I'm going to discuss the Australian Mathematics Competition 2022 Senior Division Solutions. If you haven't already subscribed to this channel, hit that subscribe button below and join us on this mathematical journey. Let's move on to the solutions. The temperature is 4 degrees Celsius. However, it drops by 7 degrees Celsius, which is 4 minus 7, which is negative 3 degrees Celsius. So the answer is C. Since the area of the rectangle is 135, we can find h by dividing 135 by 15. This gives 9. This means that the answer is B. Five to the power of 1 is 5, 4 squared is 16, 3 cubed is 27, 2 to the power of 4 is 16, and 1 to the power of 5 is 1. We can add this up to get 65. This means that the answer is E. The lowest common multiple of 20 and 22 is 220. We get the fraction where 11 minus 10 over 220 is equal to 1 over 220. This means that the answer is E. We can mark the points of the square with the correct coordinates. We can find the point of intersection by finding the average of the different coordinates. This gives us the x value, which is 1 plus 7 divided by 2, which is 4, and the y value, which is 8 plus 4 divided by 2, which is 6. This means that the midpoint is 4 and 6. So the answer is A. The height of the trapezium is x. To find the area of the trapezium, we have to add 3 and 5 together, divide it by 2, and multiply by x to get 4x. Now we can find the area of the parallelogram, which is x. The ratio is x over 4x, which can be simplified to 1 in 4. So the answer is C. We already know that the total of these cards is 4 root 5. To find the largest total of 5 of these cards, we have to subtract the smallest of these cards, which is negative 4 root 7. So the new total is 4 root 5 minus negative 4 root 7, which is 4 root 5 plus 4 root 7. This means that the answer is E. The angle sum of a quadrilateral is 360 degrees. This means that x plus 230 is 360 degrees. This means that 2x is 130, so x is 65 degrees. So the answer is A. The only way of obtaining 12 is 11 on the large dice and 1 on the small dice. Since these two rolls are independent and the probability of rolling an 11 is 1 in 6 and the probability of rolling 1 is 1 in 2, we can multiply these together to get 1 in 12. This means that the answer is D. In this question, the best strategy is approximation. The answer is approximately equal to 25 to the power of negative 1 over 2 plus 16 to the power of negative 1 over 4. This is equal to 1 in 5 plus 1 in 2, which is 0.5 plus 0.2, which is 0.7. The closest of the 5 options, so the answer is C. Imagine that the special symbol is an asterisk. Suppose that P asterisk Q is equal to Q asterisk P. Then 2P minus Q is equal to 2Q minus P. This means that 3P is equal to 3Q. Consequently, the only pairs are where P is equal to Q. Conversely, every pair where P is equal to Q has P asterisk Q is equal to Q asterisk P. So all the possibilities from negative 6 to plus 6 all works. This accounts for a total of 13 possible pairs. This means that the answer is B. Suppose that the radius of the large circle is A, the radius of the medium circle is B, and the radius of the small circle is C. We get that A plus B is equal to 13, A plus C is 9, and C plus B is 8. We can add all three of these equations up, and then we get 2A plus 2B plus 2C is equal to 30. We can divide this equation by 2 to get that A plus B plus C is equal to 15. From equation number 3, we know that B plus C is equal to 8. This means that A is equal to 7. Therefore, the answer is C. The 5 numbers have integer mean, so the sum is a multiple of 5. The original 4 numbers add to 26, and the 5th number must be between 3 and 11 but can't be 4, so the 5th number must be 9. This means that the sum of all 5 is 35, and the new mean is 35 divided by 5, which is 7. This means that the answer is D. Using Pythagorean theorem, we can find the length of BC, which is 2 squared minus 1 squared, which we find the root of, which is root 3. We know that ABC and CBD are similar triangles. Using the rules of similar triangles, we find that AB over AC is equal to BC over BD. This means that 2 divided by 1 is equal to root 3 over BD. We can solve this to get that BD is equal to root 3 over 2. Once again, by using Pythagorean theorem, we can find the length of CD. We can simplify it to get that CD is equal to 3 over 2. This means that the answer is B. We get that 3 to the power x is a common factor. We can simplify this equation to get that 3 to the power of x is equal to root 3 or 3 to the power of 1 over 2. This means that x is equal to 1 over 2. So the answer is B. First of all, we need to find the difference between 1 over 22 and 1 over 20. To find the value of y, we get the first number, which is 1 over 20, and plus it by 3 multiplied by the differences, which is 1 over 22 minus 1 over 20, where 3 comes from because y is 3 places away from 1 over 20. We simplify this to get that y is equal to 2 over 55. This means that the answer is D. We can label the triangle as per the diagram. The length of QU is 2/8 of the length of PQ. The length of Q2 is 6/8 of the length of QR. Using this information, we can find the area of the triangle QUT as a fraction of the triangle PQR. In a similar way, we can find the areas of the triangles PUS and STR. Each of them are equal to 3/16 of PQR. This means that the total area of these three triangles is 3/16 multiplied by 3, which is 9/16 of the triangle PQR. We have to minus this area from the whole triangle, so the area of SUT is equal to 7/16 of PQR. Therefore, the ratio is 7 to 16. So the answer is B. Let's label this pyramid as per the diagram. We know the volume of P is equal to 1/3 multiplied by a squared multiplied by x. This is equal to 5. The volume of the whole pyramid is 1/3 multiplied by 3a squared multiplied by 3x. We can rearrange this to get 27 multiplied by a squared x over 3. We know that a squared x over 3 is equal to 5, so the volume of the whole pyramid is 27 multiplied by 5, which is 135. The volume of P and Q is equal to 1/3 multiplied by 2a squared multiplied by 2x. We can once again rearrange this to get 8 multiplied by a squared x over 3. Substitute in a squared x over 3 for 5. 8 multiplied by 5 is equal to 40. The volume of R is equal to the volume of the whole pyramid, which is 135, subtracted by the volume of P and Q, which is 40. This is equal to 135 minus 40, which is 95. This means that the answer is D. Substituting the values of A1 and A2 to find out A3, we get 2 plus 1 divided by 1, which is equal to 3. In a similar way, we can find the A4, which is 2, A5, which is 1, A6, which is also 1, A7, which is 2, A8, which is 3, A9, which is 2, and A10, which is 1. We find a pattern of 1, 2, 3, 2, 1, always repeating. This has 5 terms in it. Every fifth term is equal to 1. We need to find A100. A100 is divisible by 5, so A100 is equal to A5. Term number 5 is equal to 1. This means that the answer is A. We can apply Pythagorean theorem to the triangle ADB to find that AB squared is equal to 65. Now we can apply Pythagorean theorem to the triangle AEB to find that AE squared is equal to 49, so AE is equal to 7. Using this, we can find the area of ACB, which is 8 times 7 divided by 2, which is 28. This means that the answer is B. Using Pythagorean theorem, we can find half of the dotted lines, which is root 2. So one dotted line is equal to 2 root 2. So its volume is 2 root 2 cubed, which is 16 root 2. Now we need to consider one of the cutoff pyramids. It has 3 dotted edges, each of length root 2. The area of its base is 1/2 multiplied by root 2 multiplied by root 2, which is 1. So its volume is equal to 1 over 3 multiplied by 1 multiplied by root 2, which is root 2 over 3. However, there are 8 of these cutoff pyramids, so the combined volume is 8 multiplied by root 2 over 3. So the total volume is a whole cube minus the 8 cutoff pyramids, which is 16 root 2 minus 8 root 2 over 3, which is equal to 40 root 2 divided by 3. This means that the answer is B. We get the equation dy plus E is equal to F. To minimize x plus y should be negative, so F should be less than E. For the smallest value of y, F must be equal to 2, E has to be equal to 9, and D has to be equal to 1, meaning that y is equal to 2 minus 9 divided by 1, which is negative 7. So x plus y has to be greater than negative 7. Now getting the equation ax minus b is equal to c, we can rearrange it to get that x is equal to b plus c divided by a. X must be positive so that x plus y is as minimal as possible. This means that b has to be equal to 3, c is equal to 4, and a is equal to 8. So x is equal to 3 plus 4 over 8, which is smaller than 1. So x plus y is less than negative 6. Whether or not this is the smallest possible value of x plus y, we know that this smallest value must be between negative 7 and negative 5. This means that the answer is B. We can mark the radii of the circle as r and the side length of the square as p. So the area of the square is p multiplied by p, which is p squared. We can use Pythagorean theorem to find a relationship between p and r. We get that r is equal to root 5 multiplied by p divided by 2. Substituting this value for p, we get that p squared, or the area of the square, is also equal to 4r squared divided by 5. Since the larger triangle is divided into smaller 4 triangles, we can find the area of the big triangle. Since the area of one small triangle is r multiplied by r divided by 2, we have to multiply this by 4 to get the area of the large triangle as 2r squared. So the ratio is 4 over 5 r squared to 2r squared. We can simplify it to get 2 to 5. This means that the answer is C. We can find the total amount of possibilities by finding different parts. For example, if 1 is in the corner, there's a total of 4 possibilities. However, there are 4 corners, so we have to multiply 4 by 4 to get 16. Now, if 1 was in the center, there's a total of 3 possibilities. Since there are 4 center grids, and for each center there are 3 possibilities, we have to multiply 4 by 3 to get 12. So the total number of combinations is 16 plus 12, which is 28. This means that the answer is D. I is my speed, S is Sally's speed, and W is Wally's speed. D represents the distance around the lake. Since I take a total of 77 minutes to complete the distance around the lake, the total speed of I is equal to D over 77. Since me and Sally takes a total of 42 minutes to go around the lake, we can get an equation using relative speed of I plus S multiplied by 42 is equal to D. So this means that Sally's speed is equal to D over 42 minus D over 77. And since me and Wally take 44 minutes to cross the lake, we get an equation where I plus W multiplied by 44 is equal to D. So W is equal to D over 44 minus D over 77. Since we need to find the difference between the time that Wally takes and the difference at the time that Sally takes, we know that this is equal to D over W minus d over s. Substitute in the values of w and s we found earlier, we get an equation which we can simplify to get 77 multiplied by 2 over 15. This is approximately 10. This means that the answer is E. The regular hexagon consists of 6 equilateral triangles, each of area 10, which can be used as a measurement grid. The diagram shows the only 3 different types of triangles that Horton measures. Using the grid, we can measure each triangle's area, and by considering rotations and reflections, we can count how many of each type there are. In this diagram, the area of the triangle is 10 plus 5 plus 5, which is 20. There are 12 of these triangles. In the next diagram, the area of this triangle is 5 plus 5, which is 10, and there are 6 of these. In the last diagram, the area of this triangle is 6 multiplied by 5, which is 30, and there are 2 of these. We can calculate the total area of the 20 triangles below. The total area is 360. Let the square, cube, and fourth power be s, c, and f, respectively, with f is equal to s multiplied by c. We are told that s is even, so f is an even fourth power, which, to be as small as possible, must be of the form f is equal to 2 to the power 4 multiplied by 3 to the power 4x, where x is greater than or equal to 1. Since c is an odd cube factor of f, it must be of the form c is equal to 3 to the power y. This means that s is equal to 2 to the power 4 multiplied by 3 to the power 4x minus 3y. But s is a square, so the index 4x minus 3y must be a non-negative and must be an even. The smaller solution is when x is equal to y is equal to 2. So s is equal to 2 to the power 4 multiplied by 3 squared, which is 144. So c is equal to 3 to the power 6, which is 729. This means that s plus c is equal to 144 plus 729, which is 873. This means that the answer is 873. Since we already know the first 2 terms, which are 2 and 6, we can find the third one, which must be 12, because 12 plus 2 divided by 2, which is 7, minus 1 is equal to 6. We can find the fourth term, which must be 20, because 20 plus 6 divided by 2, which is 13, minus 1 is equal to 12. In a similar way, we can find the other terms, which must be 2, 6, 12, 20, 30, 42, and 56. We can find a pattern because the differences between each of these terms are 4, 6, 8, 10, 12, 14, where each difference differs by 2. We can write an equation where 2 plus 4 plus 6 plus 8 all the way up to plus x, where x is the last term, is less than 1000. Using the sum of series formula, which is n over 2 multiplied by a plus l, where n is equal to x over 2, a is equal to 2, and l is equal to x, we get an equation where x over 4 multiplied by 2 plus x is less than 1000. We can rewrite this equation to get that x multiplied by 2 plus x has to be less than 4000. We want this to be as large as possible, so x has to be as large as possible. The square root of 4000 is approximately 63. This means that x has to be less than 63. We can try the possibility if x is equal to 62. Substituting 62 to x in the equation x multiplied by x plus 2 is less than 4000, we get 62 multiplied by 64. If we multiply this, it gives a product which is less than 4000. This is the largest value x can be. So when we get the equation 2 plus 4 plus 6 plus 60 plus 62, we know that this sum is equal to 992. This means that the answer is 992. At the beginning, stage 0, Rain has the unstamped original. So there is one sheet with 0 occurrences of the copy stamp. After stage 1, he has the unstamped original plus 2 stamped copies. So there is one sheet with 0 stamps and 2 sheets with 1 stamp. After stage 2, he has the unstamped original, the first 2 copies, and 2 unstamped copies of each of these. So there is one sheet with 0 stamps, 4 sheets with 1 stamp, and 4 sheets with 2 stamps. We can set up a table to track the number of sheets with the given number of stamps. At each stage, the number of sheets with K stamps is equal to the number with K stamps at the previous stage. However, those which are fed through the copier are not restamped, plus twice the number with K minus 1 stamps at the previous stage. Also, there is only ever one copy with the no stamps, being the original sheet of paper. Since we are interested only in the number of copies with 2 stamps, we can complete the most important part of the table. Let's complete the table. Once we complete it, we find that after 8 stages, there are 112 sheets with the 2 stamps. This means that the answer is 112. Let's label the runners from A to E, and we'll use notations like C followed by an up arrow to mean that C's place in the second race is higher than in the first. Then E followed by an up arrow and A followed by a down arrow. On the other runner, we'll move up in the ranking given 3 cases: B going up, C going up, or D going up. In the first case, B will go up, E will go up, A will go down, C will go down, and D will go down. The possibilities for the second race are then shown in Table 1. B must move up to first place, and D must move down to 5th place. C will go down to 4th place, then A and E can go in either order. Table 2 summarizes possibilities if C goes up, E goes up, A goes down, B goes down, and D also goes down. D must move down to 5th, and only C or E can end up first, so you consider those separately. If C is first, then second must be A or E. Also, B must be third or fourth. If E is first, then C must be second. This leaves A and B for third and fourth as shown. Table 3 summarizes possibilities. If D goes up, E goes up, A goes down, B goes down, and C goes down. The 6 columns consider the 6 subcases as based on the first and fifth positions. Note that C must finish fourth or fifth, so the subcases where A or B finish fifth must have C finish in fifth, given very few possibilities. In the first table, there's a total of 2 possibilities. In the second, there's 4 plus 2 possibilities. In the third, there's 1 plus 2 plus 4 plus 1 plus 2 plus 3 possibilities. We can add all of these up to give 2 plus 6 plus 13, or a total of 21 possibilities. We have now completed the 2022 Senior Solutions. Thank you for watching. Make sure to subscribe and share this video with anyone else you would think would benefit from it.